Okay, so for review for the quiz tomorrow, I'm just going to do a couple problems here to help you kind of be prepared. So the first one I'm going to do is talking about domain, range, end, behavior, that sort of thing, and transformations. So let's say, for instance, I have a quadratic. Looks like this, okay? Vertex is here at 1 and, I don't know, let's say -3. So in terms of the equation itself, we know that because it's moved to the right 1, that's x minus 1. Oops, sorry, forgot the x minus 1, quantity squared, then shifted down 3, that's on the outside, so that's -3. Then if we want to look, say for instance, a point, so let's say, I don't know, at 2, okay, so at 2 here, what's the value? For a typical function, if we move over 1, so if x were 1, and we square that, if that's the parent function, x squared, so if we put in 1, if x is 1, then y is 1. Then what we're doing here, again, if we're moving it over 1, so we've gone over to the right 1 spot. Let's say the value of the function now is here, which is at -1. So instead of going up 1 unit, which would have put us at -2, it's actually gone up 2 units. So how is that possible? For it to have moved up 2 units, then that means we've had to multiply the y by 2. So that would be the transformation. In terms of the domain is our x's. Because it opens up, both up and into the left and right forever, our domain is -infinity to infinity. Our range is, it starts at -3 and then goes up to infinity. As far as end behavior, so I'm going to use blue here. For end behavior, as x approaches -infinity, so as we go to the left on the function here, we are going to, so f of x or y, depending on what the notation is, goes to positive infinity. Then as x goes to positive infinity, so again, as we move to the right, the function f of x is going to positive infinity. So that's end behavior. So another example of something we talked about was inverse, okay? So let's do a real quick example of an inverse function. So say for instance, my function f of x is, I don't know, 1/3 x minus 6. If I want to find the inverse, remember what we did, Coach Brown did, we replaced the f of x with y, then we're going to switch these out. So now we get x equals 1/3 y minus 6. Now we need to isolate the y. So we add 6 to both sides. So we get x plus 6 is 1/3. To get rid of the 1/3, we multiply both sides by 3. That means I've got to use distributive here. So the 1/3 and the 3 cancel, so now I get 3x plus 18 equals y. And then we said, instead of y, you put the inverse notation. So that becomes the inverse function. We'll continue with looking at how can an inverse be 1-to-1. Let's say, for instance, we're doing a table of values, okay? And say this is a function 2, 3, 3, 4, 4, 4, 5, 6. Okay, that is a function because, and it is 1-to-1. For every x, there's exactly 1 y. Okay, so how would the inverse work? So the inverse I'm going to write in blue here. So the inverse would become 3, 2, 4, 3, 4, 4, 6, 5. The inverse is no longer a function because the x value y, or the x value 4, sorry, has 2 y's. So if you think about it, plotting it on a graph, and I'll do that in black down here, if I go to the point 4, I would go 3, and then I would also have 4, 4, and now it does not pass the vertical line test. So that is no longer a function. So just because that the original function, original relationship is a function, does not mean that the inverse is a function. The last thing we'll look at real quick is talking about increasing, decreasing. So again, just draw a quick graph here. Okay. So say that's at -2, say that max is at 1, say that's at 3, that's at 5, and this is at 7. Okay, so where's the function increasing? We'll put endpoints on this. Okay, so the function is increasing from here up to here, but it's also increasing from here to here. So anytime there's a max or a min on either side, it's got to be either increasing or decreasing. Well, in this case, it's increasing on the left side. Here it's increasing on the right side. That's because that's a max, this one's a min. Where is it decreasing? It's decreasing in between those two. Okay. So again, doing intervals, if I'm saying increasing or saying where the slope is positive, those sort of things, then I need a value here. So let's say this is at, I don't know, -4. So it's increasing on the interval from -4 to 1. So again, from here to here. Again, use parentheses because here at 1, it's neither increasing or decreasing. And here, we don't know what it's doing on the other side, so we can't put that. But it's also increasing from 5 to, and again, I need a point over here. So let's say that's at 8. So we say from 5 to 8. So then decreasing, or where the slope is negative, then would be between 1 and 5. And that goes, again, where those end. So hopefully that's a good little quick review for you.